All right, welcome. We're going to get started. So, I wanted to thank you for coming today and just give you a brief recap for those of you who just joined. Again, you will be on mute. You will have the ability to answer questions either through the chat box or through the question and answers box. Additionally, if you run into any internet connections, you will receive a recording of this webinar when it is over. So don't worry if even if you need to step away, not a big issue. We're only going to keep you here for about 30 minutes tops. We like to keep these webinars short and simple. And of course, today the topic is responding to incidents, which of course could be a 10-day class, if not longer. And we're going to try to distill it down into about 30 minutes, where I'm going to just talk to you a bit about how us hunters at Arcadia approach investigations, how we use some of the tools that we have that are Arcadia built to respond to these incidents, to investigate them, and of course to work with our customers to try to contain the incident. So hopefully you're all able to see my screen and you're able to hear me clearly. Again, if you run into any problems, there's not much I can do at this point, but you will receive the recording. So you should be able to see what is called Snowboard. So if this is your first webinar with us or your first interaction with Arcadia, Snowboard is the interface to our agents that are deployed in our customers' networks. This is where we, the hunters, spend all of our time looking at what's going on in our customer networks, what investigations are happening, what kind of stuff we see going on, and of course, anything that looks interesting. Now, today what we're going to do is we're going to focus on a particular host that has had some interesting stuff going on. I'm going to walk you through why we would determine this to be interesting. Of course, this is a piece of malware that we custom build and deploy that actually helps us to train people and helps us to make sure that we know exactly how to respond to these things. And that's also part of what you get with the Arcadia team is not only defensive-minded people, but offensive-minded people, people who have deep experience in working on offensive operations and looking at these things from the other side, because it's absolutely critical to understand how an attacker thinks or how they're going to write malware, and even to determine potential next steps that they would take. So without further ado, we see here, this is our investigation list. So every morning, this is what exactly an Arcadia hunter is going to be looking at, although of course, much larger. This is a demo network. And we're going to start looking at things that look potentially suspicious or things that look kind of out of place. Looking at this host here, and when clicking on this investigation, is going to open up this particular screen. And this screen is actually our investigation view. So an investigation is made up of leads. So just when you see a detective on TV investigating a murder, that murder case is going to have leads that come together to kind of give context for the entire investigation. And this is exactly how we structure Snowboard to display information to us, that we have leads that make up this investigation. Now, one of the cool things that we have the ability to do is actually collaborate with one another via logs. So we can actually work together to write messages. We can say, hey, it's time to reverse engineer this thing we found. We can leave notes for one another. We can leave notes for our customer. And that allows us all to work collaboratively as a team to investigate these incidents. Now, further down into this lead list, we'll start at the bottom and just take a look at what we're seeing. So we have some information on the left that's saying, hey, at this particular time on this host, we had one suspicious thread that was found. And this is on its own could mean something potentially malicious. It could be something that's actually completely benign. But the important thing is that we want to dive into the technical information. So we're not interested in looking at fancy pie graphs or other information that doesn't give us context. We're interested in the raw technical data that's going to allow us to make judgment calls based on our experience as responders and as attackers to think about what does this actually mean. So what we can do is actually take a look at the information on the right-hand side and say, okay, well, there's a suspicious thread in VM Tools D. So VM Tools, of course, is a process that's used to help make your virtual machines run a little nicer when you're using them. And this is suspicious that we see something being injected into VM Tools. And we can actually see some pretty technical information here about what was injected, like how big the memory was of the thread, what process it was, of course, the thread ID, and where this thread was actually started, so the base address and start address of that particular thread. But what we're also able to do, which is critical in an incident, is to look at the context around when this thread injection happened. So we can do this by clicking these fancy little arrows here that bring up what's called the event stream. And the event stream allows us to take a look at what's going on before this event, what's going on afterwards. So for example, you might see someone spawn Internet Explorer, and then shortly thereafter there's another process that gets executed, and then you see a chain of events happening after that. This is really important because without context, it's extremely difficult to respond to an incident because you're kind of operating in the dark. So this little tool here allows us to very quickly kind of scroll through and see what's going on. And this is a very detailed view. If we only wanted to, for example, see all of the new processes created around this time, we can apply a filter very easily to say, okay, just show us the new processes. And we can filter it out and say, okay, here's all of the new processes that we have in this time range. Before and after. And we can also expand the time range or contract it and adjust it based on how we want to investigate this particular incident. So I'm just going to clear this out, clear the filter out, and we'll just set it back to its default state. And if we take a look down, we'll keep scrolling, and this is often what we'll do because we're building up a picture of what's actually going on. And it allows us to really become familiar with what is happening on this machine at this particular time. Often, if you don't have this information, it's very difficult to make judgment calls because sometimes you'll see things that they might look suspicious initially, but after you kind of dig into them a bit and you look through what's going on around it, it's really not that suspicious. And there is a lot of genuinely non-invasive software out there that does sometimes behave a little bit suspiciously. So scrolling through this, we can see at some point we see this thread injection occur. Now we also see some other events like a read process memory, and we're going to get into that. That's part of Snow's automatic forensic capabilities, that it's going to automatically assist a hunter or an analyst by collecting information for us. But we can see the injection happens here. We can see that we trigger a suspicious file collection, that we've pulled down this particular file. Again, we're going to cover that. We see some process hollowing after that. If you were on our previous webinar, we talked about process hollowing, where there's a piece of malware that actually hollows out a chunk of memory in a process and then shoves code in it and executes it. Then we can see some other stuff like a TCP connection. And of course, we're starting to build a picture around this time that, hey, something definitely looks suspicious. Something is definitely up with this particular machine. So when we're talking about a machine, we're talking about hosts in Snowboard. And so what we would also want to do at this point is say, okay, what else can we learn about this particular host to help aid in this investigation? So we can click on this host and a little host view is going to pop up. And I'm going to actually just expand that into its own window here by hopping over here. Now, this is pretty cool that any host in the network that we have the Snow agent deployed on, we are able to dive in to see what's installed on that machine, what investigations that machine has triggered. We can also take a look at things that are kind of more detailed, like what processes we see running, unique modules, so modules being DLLs or binaries that are actually executing on that machine. We can see the installed services, which can be really useful when you see something that's using a Windows service for persistence. But often we'll also see that there are things being installed in the auto runs of that particular machine. So this is where malware will actually use registry keys or other techniques to gain persistence so that when you reboot the machine, of course, the malware is going to get restarted so that it can actually continue to speak back to its command and control, or it can continue to suck up keyboard keystrokes or whatever it's designed to do. So clicking on that view has actually got a lot of data here that might not be apparent at first. The first thing that we always look at is this column on the left-hand side, which is the number of locations that we've seen this particular file being executed. So when we see this and we see a very low number, like 4 out of hundreds or thousands of deployed agents, that tells us that something is definitely weird with this, that we haven't seen this very often, and we're seeing this now on this particular machine. And as you scroll down, the reputation of these binaries is actually going up. That's exactly what our number of locations is. It's effectively a reputational score telling you that, hey, the more times that we've seen this thing, the more likely it is that it's okay, or that we can easily kind of explain where it comes from. And the lower the number, kind of the worse it is for that particular host. So immediately we're looking at this and we're saying, okay, so we have this strange thing in program data. Program data, of course, is not a standard place that we see VMware installing things. So this looks a little bit suspicious to us. So what we're able to actually do is then query our own database to see what do we know about this particular process? What can we actually learn from other hosts? So as you saw, just to do that again, one of the cool things that we have is the ability to just highlight any binary we want. And this little context menu saying search in objects allows us to search this vast database we have of processes, of modules, file names, and it'll come back and tell us, hey, we actually have some records for that particular object. And we've only seen this process a couple of times on a couple of hosts. We can actually look specifically at the file name, and we can say, well, we've seen that file name in 4 locations on these hosts. So again, this is also telling us that, hey, there's more than just this one host that potentially have been infected or have these suspicious processes running. So this is something that, again, is going to tell us that there's more context here. We would probably want to make a note in this investigation. Hey, let's add these hosts in. Let's make a note saying, hey, these hosts also have this exact same process there. Maybe we need to go hash those files and see what's going on. So this object database is extremely powerful because it allows us to easily drill down into what's happening on that machine and then look at exactly every binary that's involved in this investigation, every process, and say, well, where else is it located? Have we seen some of these things before? So if we were looking at that particular file, of course, we saw that it was pretty rare and that it wasn't located in a lot of other machines. But we can also see part of the investigation was VM tools D, as we saw in the leads, and we can see that that was executed in 252 different locations. So this is also telling us some information that potentially this piece of malware is injecting threads directly into VM tools and then is attempting to hide itself as a VMware product in a different directory and in the auto runs of that machine. So what can we do from a response perspective? Well, one of the things we can do, of course, is to be able to reach out to that machine and say, you know what, we're a little suspicious of this. What we want to do is actually grab that file and make sure that we have a copy of it. So by just highlighting the file path and then selecting this hand here, this gives us a small list of commands that we can run. We have a larger list of commands that I'll show you shortly. But what this allows us to do is just very simply in a couple of clicks say, okay, I want to grab this file from this host. Now you'll see that the investigation here is blank. This is because I'm doing this from the host view. If we were to do this from the investigation view, it automatically populates this in, because what we want this to do is when we task that agent and say, okay, bring us back this file, we want that file to automatically be assigned to the investigation we're working on so we can keep all the information in one place. And of course, so us as hunters, we can be doing tasks and sharing that information with each other. So again, we'll click apply, and that's going to immediately send that command off to that agent. And that agent's now going to work on pulling that file and sending it back to us and assigning it to that investigation. Often this is now where, as hunters, we are also reverse engineers. So we're going to take that file, we're going to pull it down, we're going to run it through some of our tools that we've developed, as well as traditional reverse engineering tools like debuggers or IDA Pro or hex editors, so that we can actually begin to really determine, is this something we've seen before? Is this one of our customers that's actually being explicitly targeted? Is this a piece of malware that was designed explicitly for this customer? Or is this something that's part of a larger group of maybe a ransomware family or some other piece of malware that's just been repurposed so that the hash is different? So this is also another value-added thing that you're going to get. As hunters, we are also skilled at being able to pull apart this code and analyze it and see what's going on behind the scenes. So we've done a little bit of investigation into the host. The other thing we can do, of course, is now go back and take a look at a bit more information surrounding what else is going on in this particular lead that we can kind of gain some more information from. And again, we've only really looked at this one lead, and we have a number of other ones that we can look at. But one cool thing that really assists hunters and assists our customers is the ability for Snow to automatically collect information when something weird has happened. And very easily what we can do is just expand this little key at the top, and we can see that a few things are already available for us as analysts or hunters. And that is, we see a process memory map. So this gives us a memory map of the process in question, telling us who owns what chunk of memory. Are there any pieces of memory that are flagged, that are suspicious, or that look a little weird to us. We're able to grab segments of memory just with a click of a mouse. So if we wanted to actually pull it back and analyze that memory, we can do a little bit of forensics work on it and see what's going on with it. But this is all done automatically. We didn't have to actually interact with anything. This is part of the intelligence in the Snow system that is automatically pulling this information back for us. It's saving us time and giving us highly contextual information because, as you know, as malware executes, if you get there much later and you haven't had an opportunity to run tools or something else has impacted your ability to analyze it, having some very contextualized information at the time that there was something suspicious detected is really important. So we see that process memory map. Another thing that it did was automatically collect that little chunk of memory where the thread is executing. So down here where we see this thread executing, it's actually reached out and grabbed that chunk of memory back so that we can reverse engineer it. This is really critical because, as you know, memory is not persistent. So when something writes something to disk, of course, there's a level of persistence there that you're able to retrieve. But if something writes something into memory and that process exits at some point, that memory is gone. You have no ability to perform forensics on it or do any analysis on it. Whereas with this system, we're able to get that memory right away so that we could come back much later if we needed to and actually retrieve it and still look at what's going on in that chunk of memory. So this is really important, and it's really important when we're dealing with incidents that we're able to do that. So again, this is really critical stuff that allows us to build a much broader and kind of detailed investigation. And of course, working with our customers, we're able to decide how do you want us to proceed. And sometimes that's decided in advance. Sometimes customers are very proactive and they also want to be involved. But now that we've identified something weird going on, how can we actually work to stop what it's doing for now or completely terminate it? Or what do we actually have to do to get rid of this? And again, this is going to vary depending on customers' operating policies. It's also going to depend on the particular piece of malware we're dealing with. So what we can do is we actually have a list of very detailed commands that allow us to interact with that machine. So I've already pulled up this list of commands. This is accessible through our dashboard here just by clicking on commands. And I've populated the terminate thread command already with the thread ID that we identified as well as the host. Now, this is actually a real subtle but powerful technique. So for example, if we identified a suspicious thread running in a critical process, what we've shown and done in the past is we can actually isolate that thread and say, well, we can suspend just this thread. And that actually allows the critical process to continue executing. So sometimes malware will actually corrupt the process and it'll blow up and die. Other times, if they've done it right, they will actually have this thread sitting in there in memory executing, and we're able to come along and just suspend that thread and then continue executing without destroying that critical process or destroying any evidence. In this case, if I wanted to completely terminate the thread, I can actually signal to our agent that, hey, this thread ID that we've identified as being kind of malicious, we want to terminate that thread completely and get rid of it so that it's not executing anymore. And so this is actually a really cool command that we have the ability to do and do this to any process on the machine. And we can send that off for tasking. Now, of course, some of the other ones where we demonstrate already, such as getting files, we can get some information about the file. But also, if we've identified, for example, that VMware update file that was in the auto runs, if we identify that that's a bad file and we want to get rid of it, what we can do is just simply say delete file, and we can tell the remote agent to delete the thread, or sorry, delete the file. And that allows us to just completely remove that file off of that machine. And we already have a copy of it because we reached out to the machine and pulled it back. And we already have a copy of it locally that we can operate off of. Again, in some cases, you will do this if it's a known piece of malware. Other cases, you might not want to do that. You might want to do some network isolation or some other things. And this is really driven by the customer. This is not, we don't make decisions just on our own. We work with our customers very closely when there are incidents to make sure that they're as much a part of the team as anyone else. So those are some of the file operations. Of course, you have some of the traditional stuff, like we can suspend a process. So we can just tell it to hang there while we investigate other pieces on the machine, meaning we don't want to kill the process. But we just want to hang it and then continue investigating around it, look around on the machine. We might even want to resume the malware so that we can identify where its command and control is, or we want to completely suspend it and then decide, well, we just want to kill this process altogether. and have it completely dead, and then perform cleanup on that machine. Now, this is also one of those things that there are many different best practices, and no two incidents are the same. But having strong policies helps teams to kind of approach these things in a systematic way. Sometimes we're able to clean up a stage 0 infection very easily, all on our own, with a little bit of input from the customer. Other times, of course, there's much more detailed stuff that has to happen, and we work to, for example, write reports that say, here's all the things that we discovered about it. Here's the reverse engineering report surrounding what happened with this particular piece of malware. And this varies from incident to incident, but it's a very collaborative approach between Arcadia and our customers. And that's exactly how we handle these things. So as we are approaching the 20-minute mark, as I'm sure some of you are ready for me to stop talking through your computer speakers at you, I definitely now would like to say it's time for you guys to answer or ask questions if you have any. And this is literally kind of a front to back process that I've shown you here of a malware infection, how we identify it, move through responding some of it, and how we work as a team to perform other tasks and other duties, including reverse engineering. So if you have any questions, now is a great opportunity to ask them. And I will say up front that if I'm not able to answer the question directly right now, that I will send you an email, or one of our team members will send you an email after this webinar is over. So please, if anyone has questions, use the question and answers box now. Everyone's usually shy. Don't worry, no one can see your questions, only I can. Okay, somebody would like me to show the event stream again, so I can definitely do that. Was there something in particular you wanted me to show you about the event stream, or okay, just in general? So, yep, it is. It is very cool. So, I mean, this is one of those things I think a lot of people find really neat. Is they compare a lot of like lots of people see our event stream and they kind of think, well, that's actually kind of like a security version of like a sysinternals tool, where you have this running history of stuff that's going on in that machine. And it's true. It's a very useful tool for you to understand what's going on in that machine, but also in a security context as well, that we're collecting things that you're not necessarily going to see in utilities as part of, like a sysinternals tool. We love and use sysinternals tools every day here for sure. Okay, so another question was, can I go over the point of suspending a malware process as opposed to simply terminating it? So again, I think the big thing is that if you terminate the process, as I mentioned before, you are effectively, when you kill that process, you are destroying your ability to analyze the memory of that process, for one. Secondly, you also want to kind of make sure, especially if this is on a particular machine that has some critical processes, that you're not killing this process and then taking down another process with it. So by suspending a process, you're able to investigate, does this process have handles to other processes? Are there other things we have to clean up? Can we cleanly kill it? Or are we actually going to destroy evidence if we kill it? So sometimes by just suspending it, preventing it from doing any other action. So for example, if it's logging keystrokes or it's communicating over the network, just by suspending it, you're kind of holding it in place and saying, you're not allowed to do anything right now. We're going to look around before we make another decision. And that could be, we can hold that process for as long as we need to before kind of allowing it to resume or terminating it altogether. Okay, so I had another question, which was, I still have the event stream open here. And so there is a question about what is code identity. So this is actually pretty cool. What we have is the code identity information is telling you that this particular DLL was found to be signed. So we actually pull back the code signing information about that process. So again, if you have a company that is actually signing malware with a bad certificate, you'd be able to see that here. Or if you're looking at a process that you're curious, I've never seen this process name before. What does this actually mean? And then you see that it's signed by Microsoft. Well, then okay, it's weird, but it's not something that's nefarious. It's actually just a Microsoft product that I didn't know about. And of course, you can hash the file. We also track file hashes and be able to go and query VirusTotal and say, okay, this particular hash, have we seen it anywhere else? Is it actually signed by Microsoft? You can kind of do some of your other intelligence gathering work. So hopefully that helps to answer that. All right. So I'm not seeing any other questions coming in at this time. So we managed to get it done in under 30 minutes, which is awesome. We like to keep things short and sweet. Please, if you have any questions at all, send us an email at Arcadia. We are happy to respond to your questions via email. We're happy to schedule calls, whatever works best for you. And of course, I really want to thank you for taking the time out of your busy day. We're all busy people, and we really appreciate you taking the time out to come and hang out with us online and learn a bit about Arcadia, learn a bit about snow and snow agents and snowboard. It's always a lot of fun for us to do these things. So thank you very much. I'm going to close down the webinar now, but I will hang out for a few more minutes if there are any follow-up questions. Thank you again, and we will talk to you soon.